Okay, I am getting ready to set up because I got 4 Super Breakout boards coming up. 1978 Atari, I believe. It does use a 6502. It uses a 6502 processor, 2102 RAM, which I have 0 of, LM323K, which I have 0 of. It's got some ROM back here. Pretty simple little board. It's just I'm gonna have to buy some of these. I need to buy at least a few of these. 2102 RAM. I need to buy a little bit of stock of those. You got a couple voltage regulators up here. This thing got positive alternating current voltages sent up to the board because it was regulated. All the power's regulated on board. So with my setup, I'll be able to send the 10 volts unregulated from my AR up to that board, and it can be regulated by the 323. And then I'm going to send positive 22 volts up to the 12 volt circuit, and I'm going to send negative 15 volts to the negative 5 volt circuit, and that'll be regulated down to regulated voltage on board. So I got my wire cut here for making a little harness. I got my edge connector and my fingerboard. So I'll be wiring up a harness for Super Breakout. And those 4 boards will be next. Stay tuned. Okay, I went ahead and made myself a little harness adapter for Super Breakout to plug into my main connector. Since Super Breakout is black and white, I'll be using my black and white, my little TV. Yep, so this thing is good to go. Like I said, Super Breakout actually sends up AC to the board up on this edge connector. I'm just putting DC, but a higher voltage to be regulated by the regulators that are on board. But I am sending the proper 10.3 volts unregulated up to the big regulator. So I had that tapped into off of my AR setup. So all right, I'm gonna hook this thing up and fire one up. Okay, I'm all hooked up. I'll make sure, second check, parts to parts, parts and parts. Okay, we're all hooked up, right? So let's plug this thing in and see what happens. Nothing on the screen at all. Well, it's kind of doing something. See, it takes a minute for that TV, to sync to this. So this thing is doing something. It's coming up with that. Just garbage. Okay. Well, I'm going to do some preliminary checks. I'm going to check power. Make sure my regulators are working. Make sure this regulator is working. So I'll do that. I'll look for some clock signals, some CPU signals. Just some basic poking around. All right, I'm gonna hook up my multimeter to check some voltages. All right, voltage check. I got hooked to a ground spot here, and I'm gonna go ahead and hit this 5-volt rail, and we're reading 4.89, which is plenty good. Now over here is 12-volt output. 11.84 is good. And here is the 5-volt regulator. Let's get on the output. Hopefully only the output. And we got 5.10. So our voltages are good. Boy, that thing, this heatsink gets hot. Whew, damn. That's one thing I do not like about this design that Atari had, is this corner gets extremely hot. But our voltages are fine, so we're good to go there. So what am I going to do first? Well, I need to get my logic probe out and probe reset. See if we're resetting. You know what I want to do? I want to check the voltage on right here. Can I hook my logic probe up to there? Yeah, that's a 5-volt filter. So that's where I can hook up my logic probe, which is nice, convenient. Yeah, and we'll start just probing some basic stuff, reset, and other basic type stuff. Alrighty, I'll be back. I'm gonna go ahead and hook up the logic probe and start just poking around a little bit and see what's going on. Okay, I am on the reset pin, and as you can see, it is resetting, which that's good. I mean, it means at least the reset circuit is working. The CPU is trying to execute the code coming from the ROM, and it can't. So it's resetting. So it's actually working the way it's supposed to work, which is good. So what I need to do is, I do not have any idea how this system works as far as decoding, busing, and that kind of stuff. So I need to look at the manual and go over the schematic, go over the CPU schematic, and figure out how this thing talks to stuff. And I can go from there and start educate myself a little bit on this hardware so that I know what I'm doing. Okay, I'm going to do that. I'm going to take some time to look over the schematic and find out how this thing gets through to ROM and RAM. Alright, I'll see you later. Okay guys, I've already found out the CPU that was in it was junk. So folded legs over to let me know it's no good. That's right there. Now I put a good CPU in it. And how I figured out that the CPU was bad is I was looking at the schematic and I just wanted to check the addresses. And right here's the addressing going into these 08s. And so what I did was I just probed with my logic probe the 08s. And those buffers are right here. And that's all they do is they buffer. They're right here. These three guys are the address buffers. So I was just probing, okay, input, that's the tied high, and then the output. Tied high, okay, there's nothing on that one. So you can see there's the address, yeah, it's tied high, there's the output. There's the address bit. That one is tied low. So that might be used for something else, I don't know. Anyway, the thing is, most of these weren't doing anything. So I just popped a new CPU in it, a 6502 and hooked a lead, the test pin to ground, and it came up in test. And what it's doing, I'll hit reset. I'll try to turn that up. Okay, 8. That's probably these RAM. And the third beep was high. So what I'm going to do is look through the manual for the self-test procedure and find out what beep refers to which RAM. These are the 8 2102 RAMs, which I don't have any of. So anyway, I'm going to find out which RAM it's telling me is no good. And I got 4 other Super Breakout boards. Maybe those are socketed too. Maybe I can scam one of the RAMs and see if I can get this thing to boot up and work. Let me look at the manual and find out which RAM it's telling me is bad. Okay, I looked through the manual and all it says is the 8 beeps represent data bits 0 through 7. So it was the third one, so that's data bit 2. And here's the RAM. If I can, come on. Okay, here's the RAM, and data bit 012 comes over and goes up to J4. So J4 here is the one that I'm going to look at. J4 is J, right here's J, 1, 2, 3, 4. So J4 is this guy right here. So that's the one I'm gonna try to replace. See if I got another one in one of them boards I can scam for now while I order some of these in. 0, 1, 2, 3, 4. It's actually this one. It's this guy right here. As you can see right here is 0, 1, 2, 3, 4. J4 is actually this guy. So what I'm going to do first is I'm going to take this one and like swap it with this one and see if my beeps correspond the way they should. You know, make sure that this RAM is actually bad. So I think that's the first thing I'm going to do. So let's do that. Okay, what I just did is I took J4 out and I swapped it with K3. K3 is D7, data bit 7. So it should have 7 low beeps and then 1 high beep. This is the bad RAM, the one that was saying bad. And that's D7 right there, which is K3. And you look over at the schematic, you got K3 here, and that corresponds to D7. So our last tone should be high. So let's go ahead and plug this thing in. Okay, the first beep was bad. Let's do that again. So now it's telling me the first K3. So maybe this tests backwards from D7 to D0. Let's swap it with D0. Let's put it in F4. Let's swap this one with this one. Swap these two guys. I'm trying to get this. I mean, it is a different beep, which is good. So I'm going to go ahead and swap K3, which is my supposed bad RAM now. Bad RAM. K3 with F4. All right, I'll be right back. Okay, I went ahead and replaced the RAM with one out of this board that was socketed, and it is working. So the only thing that was wrong with this is a RAM and a CPU. This thing's weird. This is what it does, and when it passes test, it just says FF down there and makes that annoying little tune. That is annoying. But yep, there we go. This one's done. I think what I will do, I'm going to replace the CPU socket, I believe, because it's an old Atari junky one. Other than that, these are nice dual wipe sockets that were used here. So that's nice. I'll probably replace these caps, all the caps on the board, and that's really it. I'll probably wash it. I'll probably hot glue down this wire good, and I'll probably just wash the board good. Super Breakout. It's in French. Weird. But yeah, there it is. Super Breakout. So that's 1 out of 4 done. I've got to buy some of these RAM. This is the bad one right here. Just go ahead and kind of squish them legs over a little bit. Put it with that. There's your bad parts. And this one's good to go. Not quite. I am gonna replace the capacitors and give it a little wash. And tack this wire down good. And that's it. Alrighty, nice, easy repair. I guess I wonder how in the hell I'm going to test the inputs on this thing. Because it uses a spinner. I'm going to have to do, I'm going to look at I might be able to use my trackball for left and right. Because I do need to be able to, I need to verify that the circuitry's working for the optical, the trackball, the spinner as it was in this. So I think what I'm going to do is look at the edge connector and see if it has like just horizontal direction, horizontal clock or something like that. If it does, I can just use my trackball for horizontal left and right. So let me look into that. I'm going to try to get something set up, and I'll be back. Okay, if you look at the edge connector, you got an output for paddle and an output for paddle 5 volts. That's 5 volts to the paddle. And I imagine you would have to send a ground to the paddle as well. So that's basically 3 wires. So what I did here is I looked up the Atari 2600. This is the system end, and here you have a paddle output, ground, and 5 volts. So I'm going to take 7, 8, and 9. I'm going to basically run the paddle, output, a ground, and 5 volts. And I bought male DB9 connectors. I just bought a 10 pack on eBay for like $5. So I'm going to solder those 3 leads off of my edge connector to one of these in those spots, 7, 8, and 9. And I'm going to use my Atari 2600 paddle. So that'll get controls, and I think I'll wire a fire. The serve button, I'll wire that too. That's right here, fire. So I'll wire these guys right here, 6, 7, 8, and 9, and run it with my paddle, so that I can use that to control the paddle thing. So yeah, that'll be cool. I gotta wait for those things that I bought. Like I said, I bought a 10-pack for $5 on eBay, free shipping. You can't beat that. So okay, I'm gonna wait for that stuff to come in. So it'll be a few days at least, and then I'll wire that up and hook it up, and we'll test controls. Okay, I went ahead and did some maintenance here. I replaced the CPU socket, I replaced the capacitors, and I washed this board. It's super nice and clean now. I tacked down the wire with some hot glue. But there is one thing that I noticed that I didn't notice before, how this is lined. That's supposed to be a solid line. I pulled it up in MAME, and that's supposed to be a solid line. So I believe there's a logic problem on this board somewhere. So I think I'm going to read the manual on this. Is really great. The actual early 70s or the 70s manuals on these things are great. So they give you a theory of operation. I think I'm going to read that and I figure out why this is lined. It's supposed to be a solid line. So I'm going to do that. Figure out what's drawing these lines or whatever. Maybe that theory of operation will help me out. So I'm just going to sit back and read that for a little bit. Okay, I'm looking at the theory of operation, and this is the playfield generator block diagram. And you have the horizontal and vertical signals and the address bus being muxed through 3 muxes and goes into the playfield RAM as an address. Data comes directly from the CPU. And the data that it outputs goes into this 8-bit latch. Now, I'm not worrying about this guy. This is like the cutoff right here, because the CPU, the program's operating. So what I'm looking at is from here on. And I said, okay, here's the 2 proms, playfield proms, P4 and R4. That's an easy enough switch. I'll just pop 2 of the ROMs from another board in those 2 spots and see what happens. So that's what I did. I took the 2 program ROMs out of this board and put them into this board right here. Here's the old ones. And now we got our solid line. So it was these guys right here. It was at least one of them. I don't know which one of them's bad. So I think what I'll do is I'll use my programmer to pull the data from those chips and then compare them against ROM ident and see which one of them's good and which one of them's bad. And I will put these guys back in this board, and I'll program whatever ROM I need for this board. It's a 82S131. They're both 512 bit parts. But yeah, that fixed this board. This one's 100% now. You can test with, well, other than yeah, see, You can hear that. Sound is fine. I'm going to wait. The final test on this board will be with the paddle thing and the button and whatnot. That's what it's supposed to look like. So I'm going to put this one aside and I'm going to wait until I get those little DB9 connectors and wire up a test thing to plug into my Atari paddle. Look how nice and clean this heatsink got. I don't know if this camera's doing it justice. This board came really clean. It's a really nice board. Okay. I am not going to bore you with the details of checking which one's bad and which one's good on that. Just know that that's what I'm doing. I'm gonna look at these two with my programmer and see which one of them, if not both, are bad, and then I'll burn new ones and put these guys back in that other board. And I'll just put this one aside, waiting for my control test. All right. Thanks a lot. Actually, I'll let you see my little setup that I make when it comes in. So, see you on the next video.